Hi there, class, all math peeps. This is Mrs. Marshall, and I'm here with a day 4 practice help video. So let's start with number 1. So the way I teach my students, I have them find A, B, C, and D. So the first step is to figure out where our midline is. And in this particular problem, our midline is right there at -1. So here's our midline. And it's at -1. Since our midline is -1, that is our vertical shift. So D is also -1. Now we need the distance from the midline to the highest point and to the lowest point. And that is only a half. So A, which is our amplitude, is 1/2 or 0.5. I personally like fractions over decimals if I can put it as a fraction, so I'll use 1/2. And then we need our B. B is 2 pi over period, or period is 2 pi over B, so they are interchangeable. And we want to figure out what our period actually is. So our period, I always like to go from whatever value is on the x-axis and then go 5 points to the right so that I can figure out a full cycle, because a full cycle would be 5 points. So that's 1, 2, 3, 4, 5. So our full cycle ends right there along that last highlighted line. So now we need to figure out what in the world that is. So that space in terms of this box looks like 1/3 of the box. So I'm going to add another little tick mark. So that means each box up until pi, I'm going to break up into thirds. So that's 1/3. And then break this box up into 1/3. That dot where pi over 4 is shouldn't be there. So that's just a little typo. Pi over 4 is actually the line. And so now we got to figure out how many pieces pi is broken up into. And if we count them, each box is divided into 3 parts. So that's 1, 2, 3 for that box. 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12ths. This pi is broken up into 12ths. So if we're trying to figure out that period ends right here on this one. And that is 1, 2, 3, 4, 5, 6, 7, 8. That is actually 8 pi out of 12, which reduces to 2 pi out of 3. And so our period is 2 pi over 3. So when we set this up over here, 2 pi divided by 2 pi over 3, we need to therefore keep 2 pi over the top, put it over 1, change to multiply, and flip. And then if we use our cross simplify, 2 pi and 2 pi go away, and 3 divided by 1 is just 3. So that tells us what B is. And now we need our C. Our C is our phase shift from the y-axis. And remember, with cosine, on the y-axis, it starts high, midline low, midline high. And this is cosine. And so we want to figure out, is it starting high and following the pattern and going down to the midline? Or is it following the pattern for sine, which starts midline high, midline low, midline? And again, this is for sine. And so we look and see, where is it starting? Is it starting at the high or the midline? And this one in this particular case is indeed starting at the high. Ta-da! And it is following the downward trend, just like a cosine does. It follows the downward trend. So this does not have a phase shift. So the answer for this is none, since it starts where we want it to start, on the y-axis. So now let's write our equation. Let's switch up the color. Y equals A, 1/2. The function is cosine. B, and we always put it in parentheses, 3. But then we have to figure out, do we need a double parentheses? Well, we don't have a phase shift, so we don't need double parentheses this time. So it's just 3x minus 1. And that is your answer. Whenever you have a period where it doesn't end on a tick mark that's there, just split up that one box that particular spot lands in, like this one, into however many pieces it looks like it's broken up into. So this one looked like it had to be thirds because they have to be equal sections. And then divide up all the other boxes till you get to pi into that many sections. and count and figure out, okay, however many pieces you divided up by, what piece out of the total pieces is that one you were looking for? Well, this was piece number 8 out of 12. So that's where we got that from. All right, let's do number 2. Number 2, it is find the cotangent of theta if sine theta equals 1/4 and tangent theta is less than 0. Okay, so step 1 for these is to figure out what quadrant you're in, because at the end of the day, you're going to have to draw a coordinate grid. But we want to figure out the quadrant. And we figure out the quadrant based on the information that they give you. First of all, it tells us that sine has to be positive. So we know sine is positive versus tangent has to be negative because it's less than 0. So when we plug it into our points, we know the first spot is C, the second spot is S. So this is our positive. And so if tangent has to be negative, we always divide sine divided by cosine to get tangent. Well, the only kind of number that you can divide a positive by to get a negative answer is a negative number. So this is negative positive. So the quadrant that we are ending up in is quadrant number 2. All right, so let's draw us a little triangle. Make sure your triangle touches the x-axis, and our reference angle is always the angle at the origin, and we can put in our values. So sine, another thing to remember, sine is always so it's O over H. So your O is 1 and your H is 4. So the opposite side is 1, so it's opposite of your angle. Your hypotenuse is 4, and we are looking for this side over here. And I'm going to name that x because that's the x distance. And then you can use Pythagorean theorem to solve it. A squared plus b squared equals c squared. And we have 1 squared plus x squared equals 4 squared. And keep on solving. So x squared equals, well, 4 squared I know is 16 minus 1 squared, which is 1, is 15. And so x equals the square root of 15. It does not simplify. And I'm going to add that to my diagram. And so I now know what the A, and the O, and the H, A, and H are. So let's figure out our final answer. It's asking what is the cotangent. So cotangent is the opposite of tangent. And so if tangent is TOA, O over A, then cotangent is A over O. And our A value is the adjacent, so that's square root of 15, over our O value, which is 1. Oh, but don't forget one thing, one very, very, very important thing is that because we are going to the left for this value right here, that means our answer has to be negative. It must be negative. And so we need to make sure that we put a negative on that square root of 15 so we can go left in the direction that it's actually going. So as we are solving this, we can't forget about this negative sign, negative square root of 15. And so our final answer is negative square root of 15 because it divides by 1. It's just negative square root of 15. And that is our answer. Let's do number 3. All right, it says find the secant, and it's giving us some stuff. Cotangent is negative 4/3, and cosine is less than 0, so it's also negative. So our cotangent is negative, and our cosine is also negative. So then I start with my parentheses. I know that this is C and that's S, so that's our negative. But we want our cotangent, which is opposite of tangent. So when we divide it, it should be negative. So this has to be positive because a negative divided by a negative would be positive all over again, and we don't want that. So it's positive. And I'm doing my quadrant. And so it ends up in the second quadrant again. And here's my reference angle. And then now I need to figure out what is cotangent. Well, if cotangent is the opposite of tangent, which is O over A, then again, this is A over O. And so A is negative 4 and O is 3. And let's plug it in. Negative 4 is our adjacent. That makes sense because we're going to the left. Makes sense. Opposite is positive 3. We're going up, so that's positive. That makes sense. And then a squared plus b squared equals c squared. Some of you know your Pythagorean triplets. If you don't remember, like me, you can always plug in this Pythagorean theorem. And so that ends up being 25 c squared, so c equals 5. Ta-da! And so this c side equals 5. I named that side c because it's not an x distance or a y distance. So ABC out of the Pythagorean theorem, hypotenuse is c, so I labeled that one c. And now let's find our answer. We want the secant of theta. So secant is, again, another inverse. It's not one of the numbers in our actual coordinates. So we have to do the opposite or the inverse of this, which is the cosine. And so if cosine is so that's a over h, then secant is h over a. And so our h is 5, our a is 4, and don't forget, it's negative 4. And so our final answer is 5 and negative 4, 5 over negative 4, or negative 5/4. The negative, as long as you put it a part of your answer, it doesn't matter if you put negative 5/4 or if you put negative 5/4 or if you put 5 over negative 4. As long as you have that negative somewhere, then you are good to go. And that is the final answer. All right, next section. Number 4 and number 5, Mrs. Fisher did in her videos, so y'all should be good to go on those. Number 6 is just like the one that Mrs. Fisher did in her video, but I'm going to start you off on this one because it doesn't give you the y value, but it's literally just like the 2 I just did up above. We just need to create a right triangle up against the x-axis still, and then we're going to put in our value. So negative 5, since I know that I have this value of negative 5, I want to put negative 5 in this right spot. Well, that's the x value, so I'm going to put it on the x-axis. And then we want the y value. What in the world is the y value? So that's what we're looking for, going down. So we'll do the same exact thing. A squared plus b squared equals c squared. Our a squared in this case is negative 5. And don't forget to put your negatives in parentheses. B squared, which in this particular case, we're going to label that y. So this is just y squared equals, and our c is 13 squared. All right, and now we solve it. So this is going to be y squared equals, well, 13 squared minus 25 squared, so that's 169 minus 25, which is 144. And oh, this is another Pythagorean triplet, and it's y equals 12. But remember, this thing right here is going down, and since it is going down, it is negative. So when we put in our answer, this is y equals a negative 12. So don't forget that, because it's got to go in the direction. The sign has to match the direction it goes. And now you can do all the stuff. Sine, cosine, tangent. You know what the O, the A, and the H are. Again, this is your reference angle right here from the origin. And you got it. You can go from there. All right. Almost there. 7 through 14. All right. So just to recap, you should remember this is the reference angle. That's square root of 2 over 2. This one's the reference angle. That's pi over 3. And you can always use the finger hand trick. So that would be, okay, pi over 3, that goes with 60. So that would be putting down the ring finger. So then that means that's 1/2 square root of 3 over 2. Another one, pi over 6. Another one, these pi's over 3s. You can figure out those. The ones that we can't figure out are the ones I left unhighlighted. So starting with number 9. So since it's in degrees, we want to figure out how many times does 360 go into 390. I just think of it going in one time, and then how much more do you need? You need 30. And this 30 actually is the same thing as pi over 6. So when I go in my circle, I know that I'm going to start start, excuse me, I don't know, start, I don't know what I'm trying to say. I'm going to start at the 360, which technically is a full circle, but it's in this spot. So instead of doing all these circles, I'm going to start at the spot that essentially the circles would stop at, and then go the additional distance. So my circle would end up stopping here, and I need to go an additional distance of pi over 6 or 30 degrees. The reason I need pi over 6 is because that lets me know that, oh, the reference angle that I'm looking for in terms of quadrant or coordinates is pi over 6. So that's putting down my finger, square root of 3 over 2, comma, 1/2. And we want the sine of this bad boy. So the sine is 1/2. Final answer, 1/2. Next one, secant. Secant of 325 pi. So again, I'm not about to go around this thing 325 times. That is ridiculous. You are either going to end up on the even side or you're going to land on the odd side. And 325 is odd. So we're going to land right here and not over there. And since we land there, there's no additional leftovers like we had for number 9. So this is our spot. Oh, let's put that back. And so that value is -1, 0. And since we want the secant is the opposite of cosine. You always got to do the opposite so that you can figure out which coordinate you actually want, which actual x or y value. So the opposite of cosine, well, cosine is the first spot. And the opposite, I keep saying opposite, I mean inverse. Inverse, I use it interchangeably, but the inverse is -1/1, which is still just -1. All right, let's do one like that we probably should know how to do and lead us to number 12. So pi over 6. Pi over 6, we already know the reference is square root of 3 over 2, comma 1/2. And 6 goes into 35. 5 times, and that's 30. So we need 5 more to get to 5, 6. So I'm going to do the even odd thing. Well, 5, which side does it land on? Does it land on the even side or the odd side? It definitely lands on the odd side. And so we need 5, 6 more to go. So instead of going half a circle or less than half, that went kind of sloppy, less than half, we actually going to go more than half. So we end up in the quadrant 4, which is positive negative. And we want the cotangent, which is the inverse of tangent. So instead of us wanting tangent, which is O over A, we want the cotangent, which is A over O. Now remember also, this is cosine, and cosine is A over H. This is sine, and this is O over H. So instead of putting the whole fractions, some of your teachers may have done the whole fractions. A shortcut is to know that the top numbers are the A's and the O's, and the bottom numbers are the H's. So if you just get rid of the H's, you can use SOHCAHTOA and use just the A and the O instead of using the whole fraction of the whole ratio. So our A is square root of 3 over our O, which is 1. And so our final answer, since we want tangent, we know that one of these have to be negative. So the one that's going to be negative is the second one. Well, or the sine, because that's what the sine says right there. And so we want this to be square root of 3 over -1, which is just negative square root of 3. All right, next one. This one here, we're doing the exact same thing. All right, so we know it's got to be out of 2, so it's going to land up there or it's going to land down here. This one's a little bit different. So we figure out how many times 2 goes into the number. And technically, 2 will either go into the number an even amount of times. And so, like in terms of whole pies, so it'll be an even amount. Or it will be an odd amount, but it's going to be the even plus a half. So instead of it landing here and here, it's actually going to land here or here. And you can always ask your teacher more questions if you're not understanding completely. You also could divide so that you can see, okay, how many times is 2 going to 57,801? And that's a whole bunch of whole times, which is an even amount. And then you have 1 over 2 left over. Also, you can think of it, so I'm going to cross this one off since that's the one we don't want. Also, you can think of it in terms of how much is left on top out of the even amount that 2 can go into. 2 can go into any even number. Well, this is not even by 1 more. So we're going to go an even amount, but then we need to go 1 more pi over 2. Why are we going 1 more pi over 2? Because it's over 2. And so our ending spot is up at the top. And we want the sign, but that point is 1. Nope, not 1. Sorry, guys. It is 0, then 1, and our sign is 1. So the final answer for this one is 1. All right, last one for this one, Eeny, Meeny, Miny, Mo, 13 or 14. Both of these are fairly simple. Let's go with 13. I want y'all to try 14. Tangent of 0. So I go look at it, find tangent of 0. I know 0's here, and that value is 1, 0. And then the sine of pi over 2, well, I know pi over 2 is up here, and that is 0, 1. And I just got to figure out the answers and then plug it into the equation. So the tangent of 0, that's TOA, O over A. So that would be 0 over 1, which is just 0. And then this one is sine. So this is 1. So our equation ends up being 0 minus 6 times 1, which equals -6. You're just plugging it in. All right, and the last section. So the way I tell my students is to think, what angle is the trig, so sine, cosine, tangent, whatever number. So, for example, what angle is the cosine negative square root of 3 over 2? What angle is the secant positive 2? What angle is the tangent square root of 3? That's all you're literally asking yourself. What angle is the cosecant -1? What angle is the cotangent square root of 3? And what angle is the sine negative square root of 2? So you're asking yourself, what angle is that trig function, that number? And so when you do this, you need to think of the coordinates. And it needs to be something that's on the actual circle. So sine and cosine, those are the two coordinates that are on the circle. If you're dealing with a tangent, you need to think of it in terms of sine and cosine. If you're dealing with secant, cosecant, think of it in terms of cosine and sine. So doing the first one, we want to figure out what angle is the cosine. So we know cosine is in the first spot, negative square root of 3 over 2. And now the question is, well, what could the other angles be? Let's use red. The other angle. So there's two spots on the circle where it is a negative square root of 3 over 2. It's where it's a positive 1/2, but it's also where there's a negative 1/2. And so since we have these two spots, those two spots are our answers. So now we just got to think, what quadrants are they in? If it's negative positive, well, negative positive would then be in quadrant number 2. So we need to figure out the answer for quadrant number 2. But if it's negative negative, that's in quadrant 3. So again, negative positive is in quadrant 2 versus negative negative is in quadrant 3. And now we figure out our answer. When you can use the whole entire unit circle. I gave my students a shortcut again. For the quadrant number 2, your numerator is 1 less than your denominator. In quadrant 3, your numerator is 1 more than the denominator. And in the fourth quadrant, it's 2 times the denominator minus 1. You can rewind this back and write it down. But quadrant 2, we want 1 less than the denominator. But first of all, which one of these has, like, what is the actual radian for this quadrant or for this coordinate is the question. So do the little finger trick, put it down, put a finger down so that 3 fingers are up on the left and 1 finger is up on the right. So then that's like, oh, that's the 30 degrees. Oh, that's the one with 6. So 1 less is 5 pi over 6. And in the quadrant 3, 1 more is 7 pi over 6. And that is the answer. Doing another one of these, let's do a funky one that we don't necessarily see all the time. Let's do 17, cosecant. Okay, so We don't know what cosecant is. I mean, in terms of there's no point on the coordinate grid with a cosecant. So we change that to sine because that's what it's the inverse of. So sine of theta equals, and now we do the inverse. Well, -1/1 is just still -1. I did an easy one. So now we want to do the same thing. Based on the coordinates, sine has to be -1, so that's going to be in the second spot. And now the question is, what does the first spot have to be? Well, the only spots on the actual circle where there's -1 second is a 0. And we figure out what quadrant that's in. Well, 0, -1 means we are going down. And so that's like in between quadrant number 2 and, well, quadrant 3 and 4. So it's this spot. Well, in this particular case, is that one spot. And so the answer is whatever that one spot is, which is 3 pi over 2. There are not two answers because 0 can't be positive and negative. It's only just that one value, 0. Let's do one more. Number 19. The inverse is tangent. It's like, wait, I thought you said change it to sine and cosine. Yes, but you got to use tangent, and then we're going to turn tangent into sine and cosine. So the inverse of that is 1 over square root of 3. I don't want to rationalize the denominator. I'm going to leave it as is so that I can write it in my coordinate. So you know it's tangent to O over A. So our O is over here, and our A is here. And both denominators are 2. Now, the thing is, you got to keep in mind, what could the signs be? For number 17, the signs were what they were. They couldn't be any different. But for these, either our signs could both be positive, which will give us positive answers, or they could both be negative, which would both also give us a positive answer. So we think about it. What quadrant will we get positive from? Oh, that's quadrant 1. And what quadrant will we get negative from? That is quadrant 3. And so we identify what are my coordinates or my radians in those quadrants. Also, just to note, yes, it has to be in radians because the directions are given to you in radians. So our radian in the first quadrant, well, that's pi over 6. Use your fingers again. And then in the third quadrant, well, that's 1 more than the denominator. So that's 7 pi over 6. And the rest is for you to try. Check out my website for the answer key to this, and I will see you next class. Marshall out.